Okay. Let me just. Okay, we're streaming. I don't know if I'll publish this, but for now it's being streamed. Anyway,
Hmm.
solution. Oh, this is the solution on the left? What do you mean solution?
Well, yeah, this is how it's solved. But
Oh, this
after
is.
you read, because I have a
Okay.
question, I
Mm-hmm.
have questions about the methodology
Okay, okay.
here.
All right, let's read together. So identify and set up figure 2.6b, whereas I see a B. I don't see figure. So we're missing the
It's 2.6.
question.
No,
Where
no, no, it's there. It's there.
I don't see a figure anywhere. I see
You see where it says 2.6? It That
oh,
figure
oh,
there
oh,
is
oh, oh,
2.6.
oh, 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 I see another page. Oh, this is 2.6. And what did they say? Figure 2.6b. Okay, so we need to look at this. So 2.6, a cheetah attacking an antelope from ambush. The animals are not drawn to the same scale as the axis. Okay, so A is the situation. There is a jeep, a tree, there is a cheetah, and then it starts running, continues running, and then the antelope and another tree. B, our sketch, vehicle, cheetah starts at x naught 20 meters. That's the location. T equals 0. Then v1, the velocity of 1, which is the cheetah, we don't know what it is at this point, and we don't know the location x1, but we do know that the time t1 is 1 second. Okay. And then there is a delta x, delta distance, and velocity. I don't know what is AV minus. I guess this is acceleration. Acceleration times velocity minus x. So acceleration times velocity. Acceleration times velocity. That doesn't make any sense. Minus. It should be AT, maybe 1/2 AT squared, or what is? It should be VT. I don't know. I don't know. Anyway,
What are
so
you asking?
I'm looking at. You can see my screen. Let me share my stream so you can see what I'm looking at.
Okay.
Here, 1 second. Here is the link, and let me give you the link so you can actually follow me on my stream, as bizarre as that sounds. So I'm just trying to figure out. Tell me when you see it.
I see it.
Okay, so I'm just looking at this. This is v sub AV minus x. This is the
Yes.
I guess maybe this is the average velocity? Something we don't
Oh,
know.
oh, are you?
I
Oh,
just
okay. Hold
I
on.
just
So,
mhm.
um, we're trying to find the instantaneous velocity. That's what this whole thing is about. It's about instantaneous velocity. Average
Mhm.
velocity, of course, isn't that hard to find. So, like it
Okay.
could ask you what is the instantaneous velocity of 1.5 seconds, and
Okay.
I'm so
Mhm.
I have a methodology to
Mhm.
calculate this. I know
Mhm.
the problem here isn't like difficult. I
Mhm.
just don't understand
Mhm.
like why it's so long and complicated. I think it
Uh,
should be easier.
well, you said you know the average speed. I didn't look at the given. So I mean, I see the at location 20 meters. They don't tell us the velocity. Maybe it's not running yet. At V1X, they say they don't know, so they don't give
But it gives
V1.
it no,
Mm-hmm.
it gives us the equation for velocity
But
here.
but okay, I mean, what do you mean equation? What is let's go back to what is given. Let me see what is given. So let's go back to the beginning. So figure 2 6b shows our sketch of the cheetah's motion. We use equation 2.1. So I guess equation 2.1 is here somewhere. No. So where's equation 2.1? I
It's just the
see.
equation for displacement. It's just the equation for displacement.
Is it
So
delta
x,
x?
x
What is? Just
no,
tell
it's
me. Hmm.
yeah, it's delta x over delta t,
Equals
I
what?
think.
Delta x over
Delta
delta
x
t
over
is
delta
v.
t.
Okay, v is delta x over
No,
delta
no,
t.
it's just delta x. I guess it's just delta x. That's it. That's it. That's literally it.
What do you mean? Uh, Equation, you have to have an equal sign. So what equals what in 2 point? Do you have 2.1? If can I see another page? Is there another page?
Yes. Yes. I will send you all the equations, but I don't think you need it. But
I
here's 2.3. Here's equation
I
2.3.
can probably derive it. I just need to know what they're referencing. I just don't know what they're referring to. This is
Okay. That's fair.
2.3, but
Yes.
what about
Um
2.1?
yes, I'm getting there.
Yeah, take your
Here's
time. Take your time.
here's equation 2.2.
Well, I don't see 2.2 yet. I just see, okay, here's 2.2. This is, so V, I was curious what this is. Okay, average x velocity of a particle in straight line motion during time interval from t1 to t2. Oh, AV just means average, and it's not minus x, it's average in the x axis. It's just average velocity. Okay, we usually just put a line or a hat over V to denote average. That's fine. Okay, so we just need 2.1.
Okay.
It's,
2.1 is just delta x equals x2 minus x1.
that's good. Okay, so now I know what they're referring to. Okay, so let's go back. So we use equation 2.1 for displacement, equation 2.2 for average velocity, equation 2.3 for instantaneous velocity. Let me see 2.3 instantaneous velocity. That's good. That's the x.
That's what I'm having a problem with. I'm
Okay.
having a problem.
Mm-hmm.
Uh, so I have a methodology.
Yeah.
I'm I'm gonna I need to share my. I wish I could stream like my notebook because I have a notebook here, right? Um,
Oh,
well,
oh,
right,
yeah, you cannot
yeah,
video. Yeah. Mm-hmm.
yes. So what it wants you to do to find instantaneous velocity
Mm-hmm.
is take two values. For instance, if you're trying to find the instantaneous velocity of at 1.5 seconds, you would
Mm-hmm.
take uh 1.5 seconds and 1.6 seconds, and then you would put it into equation 2.2. Um, and you would calculate that. You calculate that, and what you would get is that the average velocity between 1.6 seconds and 1.5 seconds is 15.5 meters per second. Okay. And then what I want you to do is change that
Mm-hmm.
1.6 to 1.51. And so you're going to continually move that second particle close to that first particle until you have a tangent line. And that
I I'm
seems the method I'm using.
I need to see you're describing something, but I can't see it. So like particle moving closer. I'm not sure. I'm not sure I need to see what you're talking about. I don't
Okay.
know what you're talking about. I
Okay. Do you know what a secant line is? Because I'm not actually looking at my notes right now. I'm just explaining this.
A secant.
Yeah.
I don't remember. Why are we using
So if you
trigonometry?
because what you need to find the because this is how it was explained to me a while back.
Okay. Okay.
To find this instantaneous velocity, you would
Mm-hmm.
take like for instance where a tangent line would intersect on a graph and wouldn't touch any other points on the graph,
Hold
right?
on. Okay, I see. I looked online for like a bunch of pictures, so I can paste it here. Here's a bunch of pictures. But how is this relevant to our discussion?
Yes. So you see the curve?
Yeah.
So you see how the tangent line intersects it at one point and it doesn't touch any other point on the
Yeah.
curve.
Yeah.
So what it's asking you to do here is
Hmm.
it's asking you to take those two secant points and move them closer and closer to that tangent point until you get your value. So
Hmm.
it's sort of a deductive reasoning to get the tangent line because that's
Yeah.
what we're looking for here. We're
Okay.
looking for the tangent line.
Hmm.
Um,
Hmm.
and I don't think the methodology I'm using right now to find this tangent line is very good, is my
Hmm.
problem.
Okay. Why not?
And I don't my second issue is I don't know what a derivative is. So it says d of x and t of x. I don't know what that means.
A derivative is so the secant. A derivative is the secant. But imagine that the secant, the two dots, bring them closer and closer and closer together until it becomes the tangent. When it becomes the tangent,
Exactly.
that's the derivative. The derivative is the
Exactly. So
tangent.
that
Yeah.
oh, okay. So okay, then my next question is how would you find the derivative of this? Because I guess that's what I've been doing then. I guess that's what I've been doing.
So
Is finding
you
the derivative.
so a derivative of a function is pretty easy to get, but I need the function. So now the function, if the cheetah is accelerating constantly, then it's that would be
Is it
x
is
that would be
the
x something like x to the power of 2 or something. I mean x times a
no,
k, what, no, not 2, I think it's 2.
hold
uh
on. No, no, but
mhm.
this isn't a linear function. It's exponential.
Yeah, so x squared, what do you mean it's exponential? That doesn't make any. Exponential means that the acceleration is varying as relative to the location. That's like a population.
No, what I
Mhm.
what I mean by exponential is the exponent is immediately affecting the acceleration, so it is exponentially increasing as
Exponential.
opposed to linearly.
No, so you can, so e to the x, that's exponential. So usually things that grow like populations, they grow exponentially. They grow natural. It's called natural growth because populations grow exponentially. But speed, the acceleration is constant per unit time. So like usually animals, the muscle, the ability to accelerate is a constant. So from 0 to 1 mile per hour, and
No,
from one. Mhm. Go ahead.
but the acceleration isn't constant. That's what I'm saying. The acceleration here is not constant
How do you know? I didn't read through the
because the
problem.
formula.
Oh, they gave a formula?
No, no.
I didn't see it. I
Yes,
did.
for
I didn't.
the
I didn't read through the problem yet. So.
okay.
Uh.
I'm sorry. I will let you finish reading through the problem.
Oh, okay.
Mr.
So
Slade, one more question.
sure.
I'm
Hmm.
sorry. I
Yeah.
am. Is your first language English?
No. Why?
If I may ask, what is your first language?
No, I don't. I never told anyone. I don't disclose that information. Why do you want to know? If you
Well,
know, don't say. Why is it important?
um, well, I speak a second language, so I mean, like it's kind of like a
Don't tell
thing,
me.
like
Don't tell
if I
me.
speak someone that speaks my second language, then try to talk to him with that, it's
Don't.
kind of like a
Don't.
thing.
Don't. No. No, we can't.
Okay,
Too dangerous. My
okay,
life. My life is not. I have people wanting to kill me, so we don't want to give them any information. So
well, I speak Russian, so um,
I don't.
if at you do not speak Russian,
No. So I cannot help you in Russian. I can speak. I can
okay,
speak English in a Russian accent if that will help you,
no,
but
no, no, no,
probably
carry
not.
on.
Okay.
Finish reading the problem. I will.
Uh, let's read together so you can, we can help each other. Okay, so let's go. So execute A at t1 equals 1 second and t2 equals 2 seconds, the cheetah's positions x1 and x2 are x1 equals 20 meters plus. Oh, so that's a given. I should have read through the problem because I guess they give. I see a constant acceleration, 5 meters per second per second. So every second, the cheetah gains another 5 meters per second.
No.
Yeah. What do you mean no? Show me the Can you show me the problem? We're solving this in reverse. This is reverse solving, but my time is limited. I can only help you for not too long. I should have started by reading the problem because
Okay.
at this point, I realized we should have started at the beginning and not at the end.
Okay.
So let's see the problem. Mhm. Mhm. But while you prepare, tell me when it's ready. But for now, what I see here is that x1. Okay, so it's 20 meters. The cheetah was at 20. Now at x1 is t1. So at t0, it was at 20 meters. And then
Mm-hmm.
when t equals 1 second, so well, at a given acceleration of 5 meters per second, we multiply it by 1 second. So this looks like at squared. So they're multiplying to get the distance. So a times t under constant acceleration, a times t gives you the velocity. And they're saying the velocity times the time. But this is because of the constant acceleration, the velocity is linear. So they're multiplying by the time. I don't know. Can you do that?
The velocity is not linear.
Yes, under a constant. Oh, the velocity is, yeah, the velocity. The velocity is linear. The displacement is a curve, but the velocity is linear. The velocity grows linearly with time. For every second
No.
passed, yeah, this is here. The a is the change in velocity. It's a constant. It's 5. The acceleration is 5. So
No.
Mhm.
No, but look, time is squared.
No,
So
no,
it's
no.
time. So
Regardless. I'm looking at regardless. So the velocity, if the acceleration is a constant, then the velocity is linear. That's because that's the way derivatives work. That's the way things. That's math. So the velocity is the velocity changes linearly, right? Acceleration is change in velocity. So the change in velocity is always 5. I mean, we should draw a graph. I mean, I
I
need
already graphed it. I already graphed it.
show me what you got.
Okay.
Show me a graph of constant acceleration.
This is the equation.
Oh, we have a stream. Let's see. So what is the red line? What are you showing me? The red line is what? Is it x or v
It's
velocity?
x. Is
Okay, but now
its
show me.
position.
That's good, but also I want to see a graph of velocity and a graph of acceleration. Show me,
Okay.
show me the acceleration. Let's
Acceleration.
start with the acceleration. What is the
How are
acceleration?
we? How am I going to graph acceleration?
Well, the acceleration is just 5 from. Okay, did you give me the problem? You still didn't post the problem?
What do you mean
And
the problem?
the question, you're showing me the solution, but you never showed me the problem. This is the solution. You never
No,
showed
it's
me.
so no, it's right here. I can't.
Hmm.
The question. It's 4 questions.
Hmm.
Find the cheetah's displacement between t1 equals 1 second and
But
t2
this
equals
is,
2 seconds.
but this is the solution. You're showing me the solution. You're not showing me the
No,
problem. Are you?
this right here. I'm showing the problem. This
Where?
is the problem.
Where?
I
What?
put it in the chat. That is the problem.
Oh, 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 oh. Okay, okay, okay. So I never
Find the
read
cheetah's.
through. I never read this as the. I never knew this is the problem. I just looked at the drawings, at the sketches. So I needed to read the problem before anything and the sketch. I thought this is part of the solution. So do you want me to read this now?
I thought you already read it. My apologies. I thought I already read
Yeah,
it.
it's okay. No, I never read it. So a cheetah is crouched 20 meters to the. I started reading this at one point, maybe. To the east of a vehicle. No, no, no. This is I never read this. I never knew the cheetah is east to the vehicle, meaning to the right of the vehicle, as in figure 2.6a. That's fine. So the cheetah is to the east of the vehicle. That's good. So we're facing north. At time t equals 0, the cheetah begins to run due east towards an antelope. That's good. We see here that a t0 and here's t1. That's good. Towards an antelope that is 50 meters to the east of the vehicle. So at t0, I guess the antelope was at 50 meters, x equals 50. Okay. During the first 2 seconds of the chase, the cheetah's x coordinate varies with time according to the equation x equals 20 meters. That's x naught plus, and this is x as a function of the acceleration. This is x based on 5 meters per second squared. That's the acceleration. But I think it's not correct. I think it's 1/2 acceleration times time squared. So this is 2 times, because the equation of x based on acceleration, I don't know if they give it anywhere, but it should be x is equal to x naught plus 1/2 at squared, acceleration times the time squared. So we're multiplying this by time squared. So this is 1/2 the acceleration. So the acceleration is 10 meters per second squared. So this is what I see from this equation. The acceleration is 10 meters per second, basically like the force of gravity. So the cheetah accelerates, some normal rate that makes sense at 10 meters per second squared. And this is the location. This is x is a it should this should say x is a function of t. X is a function of time. Okay, that's good. So A, find the cheetah's displacement between t1 equals 1 and t2 equals 2. So how much distance did the cheetah cover between 1 second and 2 seconds? So at 1, where was it? Okay, I guess from t0 to t1, the cheetah was accelerating it's already accelerating. So we can figure out x1. So x1 is, well, we just plug in 1 for t. So it's 20 plus 5, I guess. So it's 25.
Yes.
So 25 meters, meaning x1 is 25 meters. So that's
Yes. Exactly.
find the cheetah's displacement between t1 and t2. So at t2, what is it? So t2 is time equals 2. So we plug in 2. So 2 is 4. 4 times 5 is 20. Plus 20 is 40. That means x2 is 40. 40 minus 25. What is 40 minus 20, right? So it's 15, I think. So the displacement should be 15. All right, that's A. Okay, let's go to B. Find its average velocity during the interval. So the average velocity during this interval is the average. Okay, so what is the speed? What is v1x and what is v2x? So that's a little bit more complicated. Well, we know, so we don't care about the 20. So we know that at t0, the speed was 0. And we know that it accelerates constantly at 5 meters per second. So that means after 1 second, it's at 5 meters per second. So v1x is 5 meters per second. And if we give it 1 more second, then it's going to add another 5 meters per second. I'm sorry, we said it's 10 meters per second. Sorry. Acceleration is 10 meters. We can deduce from this equation that it's accelerating at 10 meters per second. So that, go ahead.
I don't think that's a fair deduction.
Well, we know from this equation, this tells us, right? So displacement is, so x equals x naught plus 1/2 at squared. Did they teach you 1/2 at squared? Do you remember 1/2 at squared coming up?
Yes.
So this is the equation. So this is 1/2 at squared. So t squared is already here. So 1/2 a is 5. That means a is 10.
Hold on 1 second.
Sure. This is a very confusing part. You have to be fluent in understanding, the a and one. You have to be able to derive 1/2 at squared by yourself. So I'm assuming you're not a physics major. This is high school?
No, I'm not.
You're in high school?
No, I'm not a physics major, but I'm starting university soon. So I'm trying to prepare for some of my classes.
So what's going to be your major?
Mechanical engineering.
Oh, you need to know this blindfold while falling off a cliff. Yeah, you need to know this inside and out, no doubt about it. Yeah, you need to solve a lot of these problems. But you need to go slower. You need to go slower. You need to derive everything by yourself. You cannot pressure yourself. Like I wouldn't look at it as a solution. I would first look at the problem and slowly. I would first read. Did you actually read the material? Did you do the sample?
No,
This
Mr.
is
Slave. I
Yes.
did the problem and I solved it by myself without the solution. I know how to solve this.
Okay.
It's just I feel that my methodology is too complicated.
Tell me about your methodology, but why do you have a methodology? I don't see I don't have any room for methodology. If you ask me to come up with other methodologies, I wouldn't be able to. I mean, this is very straightforward. I don't see more than one way of figuring this out.
Okay, then that's my overarching point. If there is a way to do this, then what I'm doing, just finding the derivative of whatever point I select for the instantaneous velocity, then that's the simplest way to do it. I was hoping that there was an easier way to find it. That's literally everything.
This problem, up until now, I don't see why. I guess I'm not using a derivative. I'm just using. I mean, this is high school. I mean, I would have been able. I am able to solve this with high school without calculus. Up until now, we don't need calculus to understand and solve this problem. Derivatives is
Okay.
that's what we call calculus. So at this point, I don't see the need for calculus. So you shouldn't bring out the big guns, calculus, unless you need it. You should always try to solve everything intuitively.
But I'm
So
trying to understand the calculus that is going to eventually go into this.
the way you're going to understand, in my opinion, is if you first solve problems intuitively. Always try to solve things as simple as possible. Once you do that and get the right answer and you do it very quickly, I mean, do you know? I don't know if why. So yeah, I think you're pressuring yourself. You need to go slower. You need to really feel comfortable. I think you're just over pressuring. And understanding is about relaxing. Understanding, you have to let. Wait, you just left the room? Oh my god, I'm talking to myself now. Where did he go? Let's wait for him to come back. Let's see if we have comments here. So the Emperor of Masculinity, or Dharma Maharaja, says, "Hey, Mr. Slave," and calculus. Yeah, we're doing some calculus. What are the coordinates? Do this like you love this course with all you mind and heart. Put all your attention and energy to your endeavors with regards to mechanics. Yes, definitely. Yeah, yeah. I mean, mechanical engineering is the one of the most beautiful forms of engineering, I think, uh, uh, there is. I mean, mechanical engineering is beautiful. I mean, every engineering is beautiful, but mechanical engineering is unbelievable. I love math. Of course, math is beautiful. What grade is this? Is he's going to college next year, so he's preparing for college. So yeah, this is basically, yeah, post high school, pre college. Anyway, but he's gone. I don't know what happened. So I'm all alone, and it's a simple problem. So I don't know where you went. If you have any further questions, let me know. I'll gladly help. I was going to give you life advice and give everyone life advice, but Emperor of Masculinity also said what I would say. I mean, the first comment that he made, where is it? This one. So do this like you love. I wouldn't say do it like you love this course. I mean, give it time, sit and do a lot of problems and derive. Like every time they teach you how to derive a formula, an equation, be able to derive it yourself and derive it again and again and again and again and again until you can derive every equation just naturally, until you see the derivation, you speak the derivation like you speak English. That's the secret. Just practice, practice, practice derivation, and then practice using the equations. And I think that's how you will enjoy it. Joy comes from just taking it easy and practicing slowly. It's like every time you repeat the material, every time you review the material, so the first time you go through a proof, your head hurts. The second time, it hurts less. With every passing time you do a derivation, it hurts less, and then you start getting joy out of it. And every time you derive it, you get more joy. When you explain it to someone else first time, it's going to hurt your head. But when you explain it to someone else the second time, it's going to hurt less. So Emperor of Masculinity says, right, practice make, of course, practice makes perfect, but it's more than that. It's like it's like a language. It's like learning a language. In the beginning, you're learning and it's so difficult, every word, and you have to remember and memorize words. But then you practice and you speak it and you use it, and before you know it, you think, you can think in this language. So the same goes for math, for logic, for physics, for quantum physics, for general and special relativity. So you just yeah, that's my opinion. All right, everyone. Thank you, everyone, for your contributions. I'm sorry we lost our we lost, well, I don't even know. I don't remember his name, the guy that we were helping. Okay, I'm gonna stop the stream. Maybe we'll do another stream in a couple of minutes. See you later. Bye.